All right, in this question, we're looking at tungsten, and we see that it has a body-centered cubic lattice, and we're given the edge cell length and asked for the density. So we're using our density equation, which is density is molar mass times number of atoms, which we'll calculate for a body-centered cube. And then we have edge length cubed, which we're given edge length here. We will have to convert that to centimeters because we want a density in grams per centimeter cubed. And then Avogadro's number. So first thing I'm going to do is look at our BCC, which is a unit cell with 8 atoms on the corners. And remember, each atom counts for 1/8 in this unit cell, because only 8 is fitting into this unit cell, and the other 8s are all in different neighboring unit cells. And then because the unit cell is that smallest repeating amount, and then there's one in the middle. So if we count our atoms, we have 1/8 of 8 atoms. So that's one total atom. And then we have one in the middle. So plus one. So we have 2 atoms total, and that's equal to n that we'll plug in. Next thing is I want to get edge length in centimeters. It's in angstroms right now. So I am told that 1 times 10 to the 10th angstroms is 1 in 1 meter. And then I want to go from 1 meter to 100 centimeters. Don't forget to convert to centimeters. This is 3.165 times 10 to the minus 8 centimeters. Now in my equation, I need a cubed. So I'm going to cube that. And I get 3.170 times 10 to the minus 23rd centimeters cubed. Tiny number for the edge length, but that makes sense, right? That's the volume. I guess the a cubed is the volume of our unit cell, and that volume can change, right? The larger the atom, and that makes sense. If there's an atom in the center, if it's a larger atom, that edge length there is going to get larger. If it's a smaller atom, it's like a copper versus a gold or something like that. Gold is much larger, so it's going to have a larger, even though they're both a unit cell, the edge length can change. And so we're given the edge length in this one, and we're going to try to find the density of tungsten. So let's plug in everything we have. We got the molar mass, which is, we look on the periodic table, we see 183.814. Let's write out all of our units. There's 2 atoms in our BCC. Then we have a volume of 3.170 times 10 to the minus 23rd centimeters cubed. And then we have Avogadro's number, which is how many atoms there are per mole. We'll cancel our units. Atoms gone, moles gone. We're left with grams per centimeter cubed, which is what we want. Now we plug this in, make sure order of operations or parentheses if you need in your calculator. You should get 19.26 grams per centimeter cubed. Okay, so let's try plugging that in. And there we go. So understanding that it's a BCC, there's 2 atoms per cell, and then understanding that that edge length cubed is our volume. And that is something from problem to problem that can change, but we were given that edge length. Sometimes you might have to solve for radius with, so how does R relate to edge length? That will change depending on what type of unit cell it is. But there's a great example of solving for density.